time to get started. The first talk today, the keynote, is actually covering a topic that should be very, very close to everyone, every single one of you, which is continuous learning. It's a core skill for every one of us. So please welcome to the stage Pauline Vos with Never Stop Learning.
Hi, everyone. Good morning. Good morning, everyone. And thank you for, hi. This is my daughter. It's an exciting day for me. Don't all look at once because she's terrified of strangers. But this is the first time my daughter is joining me for a talk, so it's very exciting. For however long she decides she wants to, which I think is probably going to be about 10 seconds. But good morning, and thank you all for getting up early. I'm not much of a morning person, so I really appreciate everyone showing up for the early keynote. And it's called Never Stop Learning, or How Curiosity and Cross-Pollination Drive Innovation. And cross-pollination is something I find endlessly fascinating. I'm going to give you a few examples of it and tell you a few stories, and hopefully it will be interesting for you as well. Before we start, I want to kind of start you off with some music, broadly speaking. I want to warn you, it's not the most easy listening. I hope my laptop isn't set too loud. But bear with me because it's not very long. So just be forewarned, but it's going to be over soon, I promise. Here it comes. So these stills and the accompanying score you just heard are from Le Ballet Mécanique, which is kind of matches the score, really, which is a 1924 Dadaist art film, and it's considered to be one of the masterpieces of early experimental film. Now, believe it or not, this highly uncomfortable score and stills have some connection to, there goes my daughter after 10 seconds, told you, have some connection to the invention of Bluetooth, and I'm going to tell you what it is. So the story starts with this lady. This lady is Hedy Lamarr. She was born in Austria, and she didn't identify as Jewish, but she was of Jewish descent, so her family is all Jewish. And as she was growing up in Austria, it became very apparent very quickly that she was very pretty. And so she started modeling and things like that in Austria, and then she decided she was going to move to the US, where she was very quickly picked up by Hollywood, doing various saucy roles, bit of nudity, which was, of course, outrageous at the time. But then Hollywood marketed her as the most beautiful woman in the world. And she was really not known for much else until very, very recently, and I mean well after her passing, when audio recordings were found where she told us that she was actually quite the inventor. So she invented a fair many things, and she even has a few patents to her name. She's posing here, fake posing, in front of one of her patents that you can also find on Google Patents still today. And that's the patent that I want to tell you about. And the other person involved with this patent is her friend, George Antheil. So George was a pianist and a composer. He composed Le Ballet Mécanique that you just heard, the original score, which eventually was, by the way, not released with the film. I don't know why, but I think we can imagine why if we've just heard it. But he was not just a pianist and a composer. He was also a self-professed expert on endocrinology. And endocrinology is the science of the specific set of glands in the human body that excrete certain hormones. And the science looks at, it was kind of a pseudoscience at the time as well. It looks at how these hormones that you excrete can affect your physique, it can affect your personality, your moods, and stuff like that. And that is actually what drew Hedy and George together initially. Because Hedy, being a beauty queen, sought George's advice about how to enhance her upper torso with glands and hormones. So that's what initially drew her to him. But then as they started talking, it turned out that they had quite a few interests in common. Haiti loved her tinkering hobby, as she called it, so her inventions. She was very interested in technology, and so was he. He was heavily inspired by technology, machines, military, airplanes. So you may think that most composers want to invoke emotion or like a sense of romance or warmth. He really sought to make all of his pieces as cold and machine-like as possible, which, yeah, you can kind of hear that in the piece you just heard, right? It was very dramatic and machine-like. So they started talking about their common interests. And Haiti Lamar was very interested in the military. She was very pro-American. Being an Austrian-born of Jewish descent, she had actually helped a few of her family members flee Nazi Germany and come to Canada and the US, I think. So she did not like the Nazis, and she was very interested in efficient ways of battling the Nazis. And one concept she found very interesting is the concept of a radio-controlled torpedo. So the concept is fairly simple. It's a beautiful, simple diagram I made. So you have a torpedo, you have a radio signal, travels over a frequency to the torpedo, tells the torpedo where to go, tells it where its target is. Then the torpedo goes straight to the target, blows everything up, and lots of damage. So very efficient, you would say. There's only one problem, or there was only one problem at the time, is that this signal travels over a single frequency, and if you jam that frequency or intercept it, but especially if you jam it, you, of course, don't get the signal to the torpedo. The torpedo doesn't know where to go. It goes off course, misses the target. Not very efficient. Nothing is broken. So they were kind of talking about possible solutions to that issue, and they came up with this idea. So instead of having the one frequency that the signal travels over, you would have a spectrum of frequencies, and the signal would hop kind of semi at random from frequency to frequency, so that the anyone who would try to jam it or intercept it wouldn't be able to do so. And only the sender and the receiver would know the order in which the frequencies hopped. So it's kind of, the signal is kind of encrypted, right? And so this technology was called spread spectrum, or frequency hopping, because it was a spectrum, a spread spectrum of frequencies, and the signal hops from frequency to frequency. So the advantage of this, of course, is twofold. One, it makes the signal secret, it's encrypted. And two, if you jam just one frequency, only a small portion of the signal is lost. So it gives you a much more reliable signal overall. And the idea wasn't completely unique. At the time, there were a few people who came up with similar ideas. But what made their prototype very unique is one specific thing. And it has to do with the fact that they had 88 frequencies on their spectrum. Can anyone guess why it was 88? Yes, I'm guessing you're maybe musicians or interested in it. There you go. Thank you for proving my point. So, of course, George was a pianist, and what they decided to do is they would take a player piano roll. So those are those pianos that play themselves. Contrary to popular belief, those are not ghosts playing the piano. You actually feed it a roll that tells the piano what to play, of course. And so, because there's 88 keys on a piano, and they were feeding their prototype this player piano roll, the frequency, or the spectrum, was 88 frequencies. And the first test they did on their prototype was using the score you just heard. So they registered this patent. They pitched it to the US military. They were like, use this, it's going to be really good. But they were a little bit suspect because it was this beauty queen and a pianist coming up with this technology suddenly. And they were like, why is this happening? So they didn't trust it. They thought they were Nazi spies. They never ended up picking it up. And it was just kind of forgotten about in a pile of patents until conveniently, when the patent had already expired during the Cuban Missile Crisis, there was a hunt for patents. So they were digging through old patents to find ways of making their signals more reliable. And they did end up picking this up and using it in the Cuban Missile Crisis. It was also cited as a partial foundation for Bluetooth and early Wi-Fi technologies that used it for, of course, more reliable signal. So value today, this invention would have been worth a fair bit. Like, you could think upwards of $1 billion, I would say. But of course, they never saw a penny because the patent already expired. But you can still look this up. There's a QR code as well. I don't know if you think it's interesting, but it's on Google Patents under secret communication system. So, of course, they didn't have the best of luck with their invention. But I really, really love this story because it really shows you something. It shows you that, you can combine all these different facets of your personality, interests, find things in common. You've got this beauty queen approaching this man because he has this weird glandular science that he dabbles in. And she approaches him because she's a beauty queen and she wants to be more attractive. Then they talk about this technology and this military stuff that they're interested in. Then they apply his musical knowledge to create an invention, to create a solution. So even though they weren't very lucky, I think it's a really cool story that shows you that sometimes you have to pick bits and pieces from here and there, from different fields, different facets of your personality, and they all need to converge to form a brilliant idea. So, this wasn't her only contact that she had in that she talked about technology about. She was also dating Howard Hughes at some point. So Howard Hughes is a famous aviation pioneer, so a famous aviator, and you may know him from the film The Aviator, where he is portrayed by Leonardo DiCaprio. And you may also remember from the film that he was dating Katharine Hepburn, which off the top of my head, I think was Cate Blanchett. But in actual fact, also in the film, you can see that he was a bit of a womanizer. But in fact, he was such a womanizer that he basically dated half of Hollywood, including Hedy Lamarr. And he was very supportive of her tinkering hobby. And he put his entire team of scientists at her disposal. So anytime she had an idea for an invention, she could go to this team and put them to work, basically. And she even apparently helped, according to her own words at least, helped him design a set of new wings for a plane. Because apparently he was complaining at some point about this new model of plane he was designing, and he was complaining that it was not fast enough. So what she did is she went out and she bought a book. In her words, bought a book of fish, bought a book of birds, found the fastest fish in the book, found the fastest bird in the book, combined their design, and gave him a new design. And again, according to her, he then said she was a genius, quote unquote. But this whole flying study and looking at animals may remind you of someone. And you may recognize this illustration from one of the earliest flight studies that we know about by Leonardo da Vinci. Sorry, my Italian pronunciation is obviously atrocious, but you know who I'm talking about. And he came from a time where most great thinkers weren't just scientists. They were often painters, sculptors, architects, philosophers. So they had... they didn't just focus on the one field they liked to think about a wide variety of fields. But one thing he also did was look at nature to maybe solve this flying problem. And that concept of emulating nature to solve human problems is called biomimetics or biomimicry. And it is responsible for a wide variety of innovations in human history in any field imaginable. In architecture, in agriculture, medicine, even in computing, just any field you can think of. And a few examples that you may know are, of course, down feather coats, so insulating our bodies the way that cute little ducklings do with little down feathers. Then Velcro was actually, I don't know if anyone here has a dog that they've gone hiking with, but if you do, especially if you had a long-haired dog, you may recognize the turmoil of having to kind of detangle these little plants that get stuck in their fur. And so this guy who invented Velcro got the idea from hiking with his dog and having to constantly pull those little plant balls out. So that's what Velcro is based on. Then wind turbines, the wind turbines, the ones that we use for energy. Next time you see them, pay attention to their blades, because they're kind of shaped like a whale tail. And that's to decrease the wind resistance, so they can actually become more efficient because they're shaped like a whale's tail. Then wetsuits based on beavers, slick, insulating, and there's just many more, way too many to mention, that are inspired by nature. And you may think, okay, we're a room of PHP developers. How inspiring is nature going to be for our day-to-day? Well, I want to see a show of hands if any of you in your day-to-day work have ever had to deal with dismantling a monolith into multiple services. That's a fair amount, right? A lot of you have probably had to deal with that. And you may, if you've had to research possible solutions to do that, you may have come across a thing called the strangler pattern. Does that sound familiar to anyone? So the strangler pattern is coined by Martin Fowler, as many things are. And he based it on the strangler fig, which is a range of species of figs, actually. But he was staying in Queensland for a while with his wife, and they were hiking a lot, and he was fascinated by this strangler fig. And so what this strangler fig does is it's basically a tree parasite. It attaches itself to a host, and that host can be a tree, but it can also be a car or a house or whatever. So it attaches itself to the host, and then it grows an aerial root down to the soil, and then it nestles in the soil, and it slowly starts growing around the host. So again, this can take on crazy forms. You can have a tree shaped like a car. And so it wraps itself completely around the host until the host is covered completely, and it kills off the host. And that, of course, is also how this strangler pattern works, is you build microservices around your original architecture until the architecture eventually is slowly killed off. So that's one example of a nature metaphor being used. But software is actually full of these metaphors, because software is full of abstract concepts. And we can't make any sense of abstract concepts, that's just how our brains work, if we don't have something from real life, from the real world to represent these abstract concepts. I mean, who hasn't learnt about OOP design principles through a bird that has fly behavior or quack behavior, or something similar? Who hasn't seen this depiction of agile work, which you're probably sick of? I know many people hate this depiction of agile work. But again, it's, you have to take something from real life and translate it into, translate an abstract concept to something that we can make sense of. And one person who understood this very well was Ada Lovelace. And Ada Lovelace, I'm sure a lot of you know about. She was a mathematician. She was a student of Charles Babbage, who made the first conceptual, at least, computer. So basically invented an early concept of a computer. Sadly, was never able to execute it, but the concept works, on a basic level like computers do today. And she is often credited as being the world's first ever programmer. So a lot of people knew that, probably, but what's slightly lesser known is that there's lots of letters that she's written in which it becomes apparent that she saw computing as much, much more than just computations, than just calculations. She saw it for what it was, and that is that anything to do with any concept from mathematics is supposed to be a representation, a symbol for something in real life. So she saw computers not as a tool to calculate things necessarily, numbers, but she saw algorithms in the future. She pictured them creating art, composing music. So not far off from what we're doing today, actually. And on imagination, she said the following. She said, it brings together things, facts, ideas, conceptions, in new, original, endless, ever-varying combinations. It seizes points in common between subjects having no very apparent connection and hence seldom or never brought into juxtaposition. So she also was very much, she loved imagination as a tool for innovation. And she loved being interested in different fields. And so I want you to remember also in your daily life that if you don't spend every waking moment thinking, living, breathing code, you don't have to spend every free moment you have on open source software, for instance, to be a good developer. In fact, it's probably really good for you to have various interests, and those different interests can cross-pollinate your career as a developer. Development can also cross-pollinate into your real life, and you can create solutions for regular life that you take from your work. And this is also one of the reasons why I really think workplace hackathons are great. Workplace hackathons are a great way to be creative, to look at different technologies and ecosystems. But there's a side note. I think workplace hackathons are great in theory. How many of you have ever worked at a place where you get like 1 day a week or 2 days a month to work on a personal project? Yeah. So that happens quite a lot, that employers give you kind of like a day a week or two days a month. Sometimes they'll call it a hackathon. They'll call it hack days. They'll call it personal days. But it comes down to the same thing, where you can work on something of your choosing and kind of experiment. And I think that's really great. For the aforementioned reasons, I think those things and sharing that knowledge can really indirectly be applied to your day-to-day work. But I've seen a lot of the following that I think those of you who have worked at a place that had hack days or whatever they called them might recognize, is that at some point middle management comes in and they go, how can I quantify this? Because they love their OKRs and their key results. So anything that they can't kind of show on a diagram that, and say, my people did this and it was useful, they don't think has any value. So what you often see as a workplace hackathon life cycle, and what I don't want you to try and do if you introduce one, is step one is always you're just doing planned work as usual, and then someone comes up with the idea of introducing this hack day, personal day thing, and it's a creative free-for-all. Everyone's super excited. Everyone's just running around, working together, making crazy, silly inventions. Maybe someone will like do a little robot or something, or someone will pair up with a copywriter and a designer to do some cool visual stuff. But then very quickly, it becomes about visibility, because people are wondering, what are these people actually doing this whole time? So then the hackathon backlog is created. And before every hackathon, they're like, don't forget to put your work on the backlog, because then other people can see what you're doing and can join, which in theory is a nice idea, were it not for the fact that usually it feels like it's more about visibility and transparency, like you have to justify what you're doing rather than, hey, this is a tool to kind of collaborate and more efficiently. Then, and this is the absolute killer for me, is when they make the hackathon, they say you can do the hackathon, but it has to be useful for the company somehow. So it has to do with the product, it has to do with the brand somehow. And so you're already limiting yourself, usually to a certain tech stack, maybe to a product. So you're already really limiting yourself, and that whole idea of cross-pollination goes out the window. What then tends to happen to the actual work is that it no longer becomes a hackathon, it becomes refactoring stuff, fixing bugs, which is not really something that the hackathon was supposed to be about, right? We actually had a category of hackathon work at my previous job that was small product annoyances. So small product annoyances that developers had, they would just go in and like fix those things. And that would sometimes mean ship entire new features. But ship entire new features and make them go live on the day, foregoing any type of refinement, any type of prioritization, often foregoing tests, which is not great. And then, of course, what happens is complete chaos ensues because you've got things that are shipped that have not been refined and that land on some team's lap because it just happens to be in the area of the product that they are responsible for, and they may never know it was actually shipped. And now they're responsible for maintaining it when they also have their planned work. So then nobody really sees the value anymore. It's just become a pain in the ass, and so they go back to planned work. And that's the hackathon life cycle. At the end, nobody's motivated anymore. There's no real benefits to it anymore. And it's such a shame because it's such a great opportunity to try out new things, to look at another language and go, hey, maybe this library that's doing this in this language, maybe we can apply that here, or we can port something, or whatever. I know we had Freek's talk yesterday that was mentioning Nuno's pest, for instance, that comes from Jest. You know, looking at different ecosystems can really do something for you and can really make your own ecosystem a lot better. And PHP developers should definitely know that better than or as well as anyone else, because PHP gets a bad rap, right? But people who complain about PHP, and yes, this is PHP. It's just the very first version of PHP. People who complain about PHP a lot, like Freek said the other day, they haven't really been paying attention, right? Usually the last PHP they've seen is 5.4 or even earlier. So this is the very first version of PHP, and it was just a template language then. This is taken straight from Wikipedia. And we've come so far since then. I think I can confidently say, and I say this a lot actually, that PHP is quite a modern language in a lot of ways. And that is because, and it's been almost 3 decades now, and it still exists and it's thriving. It's doing really well. And the only lifeblood that it has, and you know, its continued existence is guaranteed by the community, by people going to conferences, talking to each other, sharing knowledge about libraries that they're using, taking that back home, you know, people who maintain or contribute to open source, people who submit RFCs, and the people who comment on them. You know, people who suggest new features and discuss new features, participate in the decision making, and that's all community. And I want to kind of take you on a trip through PHP's recent history from 2010 to now-ish, because I've been digging through those RFCs, and some of my favorite improvements that the language has gone through are all taken from somewhere else. You can go into those RFCs, and you can always find some reference to some other language. So let's say, don't look at this as great code. It's just a little value object to illustrate some of the changes that we've gone through. So it's just a little value object, and it takes like a shape and a color, and some options, and it validates those options in the constructor with an if statement within a switch, with an if else statement, I think. And then I missed the for each as well. So lots of nesting levels. So one thing that people like to apply these days is object calisthenics, where you're extracting things into methods, making removing all those nesting levels, making it all a little bit more readable, human readable. And so that concept was actually taken from a book. And in the book, it was all in Java. And so it was ported to PHP and given at conferences. And so people started applying that. Then in 2012, we got short syntax arrays in PHP 5.4. So instead of having to go array, bracket, bracket, we could just go square bracket, that's an array. Then 2015, PHP 7 was a big one, literally a major one. I really liked this one. This was a game changer for me. The null coalescing operator, I just think it's so nice. And it was based on .NET and C# syntax. And then we also, this is an even bigger game changer, got type declarations, which is based on various different language groups. And we got it for return types and for argument types. And what's even cooler about it is that we got strict mode. So you could have a type checking level that was, you could have two different type checking levels. You could choose which one. So you could do the default one or the strict one. And really the only reason that's the case is because they couldn't agree in the RFC which group of languages to borrow from. So then they just said, let's just do both. And then let the user choose. So I thought that was really cool. And then PHP 7.4, you get typed properties. So similar to the one previous, but for properties. Then we're getting a little bit closer to recent years. 2020, we get constructor property promotion, which is also a fun one. That one is taken from Hack. And Hack, of course, is a daughter language of PHP. So Facebook created Hack, thinking, hey, we like PHP, but there's some things that we don't love, so we're going to take it, we're going to do some changes, add some improvements. And now PHP is, in turn, inspired by Hack, which is pretty cool. I really love this improvement. Then PHP 8.1 in 2021, so last year, we got the read-only properties that can only be assigned upon instantiation, so you can only assign them once. And we can get rid of all those getters in our value objects, which is also really cool. And that was taken from C# and Rust. So, of course, there's lots more game-changing features that have been, and improvements that have been made to PHP over recent years. I'm thinking especially PHP 8, 8.1, enums, fibers, all this stuff. We've got async programming in PHP, again, based on promises, which is a JavaScript thing. Really cool that we can now do async programming. And there's lots more to come. There's, of course, another version of PHP 8.2 coming out in November. And quick recommendation, if you're into that sort of stuff and figuring out where these ideas come from, Derek Redhans has a podcast you can listen to on Spotify called PHP Internals. And they're like 10-minute episodes where he invites people who submit RFCs and talk about improvements. So it's really, really cool. And there's so much still going to happen, especially under the PHP Foundation. That's now brand new. I'm really excited what's going to happen. But the best thing about PHP, I think, is the community and how open-minded it is and how we can look at other languages. And, we can take all the flack, but we can look at other languages and say, hey, we like this. We're just going to implement this. And this is how we'll stay vibrant as a language and innovative. And so as you navigate this last day of the conference, I want you to remember that you don't have to skip that talk that isn't necessarily directly relevant to what you do every day at work. Maybe it's just interesting. Maybe you can just talk to some people at a booth because you think they have cool stuff there, cool stickers. Maybe you could just talk to someone about your hobbies, your knitting or your sports or whatever. And you never know what that cross-pollination might bring. So with that, please enjoy the rest of the conference, and thank you so much for listening.